Hi there, welcome to edupediaworld.com. You are watching the videos on number systems. So in this video we'll learn some concepts about the real numbers, how to identify whether a decimal expansion is a rational number or irrational number. Then we will learn some of the steps and rules to identify whether a given number is rational or irrational number. Then we'll learn how to convert rational decimal numbers into fraction part of rational numbers, which is very important concept, and the question on this concept is generally seen in examination, so you have to watch this section very carefully. And then at the end of the video we'll discuss some of the advanced questions and concepts again. So we follow the same again strategy and plan. We'll explain each and every concept through the example. So let's get started with the first concept, which is what are real numbers first. Okay, now the topic is the real numbers and their decimal expansion. See, as we have already discussed that real numbers have two parts. They are classified into two parts. These are rational numbers and irrational numbers. Okay, now we can very easily identify if the number is given in a fraction, because if the number is given in fraction like 3 upon 2 or 1 by 7, we can directly say that it is a rational number. But what if the number is given in decimal expansion, like say we can say the number is 0.32756 and it goes on. So whether this number is rational or irrational, so which is very difficult by directly saying that the given number is rational or irrational. So we have to identify, there are certain steps and rules to check whether the number is rational or irrational number. So first we'll discuss one example, that is we will find the decimal expansion of three numbers, then we will compare that whether the given number is rational or irrational number. So watch this example very carefully. Okay, now in this example we have to find the decimal expansion of three numbers: 10 by 3, 7 by 8 and 1 by 7. So one by one we'll solve each and every question. So first we'll solve 10 by 3. So 10 by 3, we'll divide this. Now 3 into 3, 9, the nearest part, the remainder is 1. Okay, now what we can do is we can put decimal part over here and extra 0 over here, which you all I suppose know the process, so need not to explain here. So it will come again 3 3s are 9, 1, then again 3 3s are 9, 1. So this process will continue, like this process will continue. So we can infer that this number will goes on like this: 3.3333. It will go like this only. Then let's see for the another example, that is 7 by 8 first. So 7 by 8, we have to divide 7 by 8. When we divide 7 by 8, now this number divisor is smaller than this number. So what we'll do is we'll put on decimal first and put on 0 over here. So we search for the nearest number, which is 8 into 8, 64, then 6, again 0, then 8 sevens are 56, then 4, then again 0, then 8 fives are 40. Now we are getting remainder 0. So the number comes out to be in a decimal part 0.875. Now another number is 1 upon 7. So we'll divide this number. So the number will be 1 divided by 7. We put decimal over here, 0 over here. It will come 7 ones are 7, 3, then again decimal. It will be 7 threes are, sorry, it can come out to be 7 fours are 28, then 2, 0, it will be 7 twos are 14, then 6, again 0, so it will be 7 eights are 56, then comes out to be 4, then again 0, so it will come out to be 7 fives are 35, So we can clearly see that this number will also go on like this, 0.14285. Okay, now the main part is now. So listen carefully. In this example, we have a number 10 upon 3, and when we divide this number, we get the number in a decimal number as 3.3333. But in this number, we can see that after the decimal part, we have some pattern, like 3 is repeating each and every time. So this number can be written like this, 3.3 bar. Whichever part is repeated again and again in after the decimal, so we put bar over the number. So this means this number is non-terminating. This number is non-terminating, but it has reoccurring pattern. It has reoccurring pattern. Now in this number, we after the decimal we have only 3 parts. So the number ends at 5. So this is terminating. This number is terminating, and this number doesn't follow any pattern, not follow any pattern. Okay, now if we see this number very carefully, this number is non-terminating. This number is non-terminating, and it doesn't not follow any pattern. So we can broadly classify that we have 3 different kind of cases. In one, we have remainder as 0, and we have terminating number, remainder as 0, and they do not follow any pattern. And in one, we have non-terminating, means we have remainder which is repeating every time. The remainder is repeating. See, 1 1 1. So number is, the remainder is repeating every time, but they follow a kind of pattern. Now we have another type of numbers which are non-terminating. See, because the remainder is changing every time, 1 5 3. So the remainder is changing every time, and they don't follow any pattern. So these are the 3 different type of cases for the numbers. Now we'll discuss the cases. Now the case 1 is the remainder becomes 0. We have seen in the previous example that when we divide 7 by 8, the number comes out to be 0.8875. So we can clearly see that the remainder is 0. So these type of numbers are known as rational numbers. Rational numbers. Why? Because they have terminating part after decimal. So they are rational numbers. Now another case is the remainder never becomes 0. Now in this part we have 2 classification. The one is like we did 10 upon 3, the number comes out to be 3.3333, and it goes on. So we have non-terminating, but it follows pattern. So these are also rational numbers. Now in another number we did 1 by 7, the answer was 0.1428, and it was something. So in this number we can clearly see that it is non-terminating and not follow any pattern. So these numbers are known as irrational numbers. Irrational number. So let me classify how to identify rational irrational number. If the number is non-terminating and follows pattern, it is rational number. and if the number is non-terminating and follows no pattern, then it is irrational number. And the last one is if the number is terminating simply, then it is rational number. So we have three cases to identify whether the number is rational or irrational number. So let's see some of the examples to how to use this concept. Now the example is, we have to show that this is a rational number and we have to express this as in the form of p by q. And you very clearly know that if we can express any number in the form of p by q where q should not be equals to 0, then it is a rational number. So the question is 3.14267. Now clearly we can see that it is a terminating number, and if we can express this number in the form of p by q, then it will become a rational number. So let's see how to do this. Now clearly we can write 3.14267 as 3142678 upon how many zeros? 1 2 3 4 5 6. So it will come 6 0. So now this becomes directly the form of p by q. So this number is rational number. So this was an easy question to explain how to express the decimal number into a fraction part and expressing it as a rational number. So let's see further examples how we can use this property. Now these type of questions we are going to do now in this example. These are very important questions. Let me tell you very clearly, these questions are very important because these type of questions will come in the examination. So please watch these questions carefully. You have to show that this is a rational number first, and you have to express in the form of p by q. So let's see how we can do this. The number is 0.3333 and it goes on. Now how to solve this? You have to watch the steps carefully. The step 1 is, now the number has bar on one number only, we can see clearly. So if the number has only one bar, then we multiply with 10. If the number has one bar, then we multiply with 10 only. Now like 0.3 bar or 0.2 bar means that the reoccurring part is only 1. Now if we have two reoccurring part like 0.257 and we have bar over two numbers, then we multiply with 100. Clearly we can classify that the number of bars means the bar has two numbers, then we multiply with 100. If the bar has three numbers, then we multiply with 1000. So you have to notify this part very carefully. Now the next step is, we'll suppose let x equals to 0.3333 and 3, and like this it goes on like this. Then now the second step is, we have one bar over one number, so we multiply both sides of the equation by 10. So we multiply both sides by 10. So what we get is, we get 10x equals to 3.3333 and it goes on. Now this becomes the first equation and this becomes the second equation. Now the next step is we always subtract 2 from 1, sorry 1 from 2. So what we get is 10x minus x equals to 3.3333 bar minus 0.3333. Now you can clearly see that this non-terminating part will automatically cancel out because this part is equal. So here it will come out to be 0 decimal, and 3 minus 0 is 3. So what we get is, we get 9x equals to 3, means 10x minus x is 3, so 9x equals to 3. So x will come out to be 3 upon 9. So we can simplify this, 3 1s are 3, 3 3s are 9. So the fractional part is 1 by 3, means p by q form is 1 by c. So this is how we express non-terminating rational numbers, non-terminating rational numbers into p by q form. So we'll discuss some of the more complex examples on this part only. Now the second example is, we have to show that this can be expressed in the form of p by q. Now we have the number 1.27 bar. Now we can clearly see that the bar is upon two numbers, so which clearly gives us a hint that we have to multiply the number with 100. So what we do is, we'll suppose let x equals to 1.27 27 27 and 27, and the number goes on. Now we have to multiply this equation with 100 on the both sides. So what we get is, we have to multiply by 100 on both sides. So what we get is 100x equals to 127.27 27 27 and 27. So then the second step is, we have to subtract. So this becomes first equation and this becomes the second equation. So we have to subtract 1 from 2. So what we get is 100x minus x equals to 127.27 27 27 27 bar minus 1.27 27 27 27, it goes on. Now we can clearly see that this part and this part will get cancelled out because it's equal and non-terminating. So what we are left with, 99x equals to 127, sorry, it will be 126. Now the number comes out to be 126 upon 99, and further we can simplify it. The number can be divided by 9. So 9 11s are 99, 9 14s are 126. So the number in the p by q form is 14 by 11. So this is how we can solve the numbers. So let's see another example on this concept only. Now the example is, we have to show again that this number can be expressed in the form of p by q. So again the number is 0.235 bar. So what we do is, we suppose let x equals to 0.235 35 35 and 35, and it goes on like this. Now we have bar upon two numbers, so we multiply with 100. So what we get is 23.5 35. Now we'll get 35, 35 and 35. Now here comes the tricky part. So it will become, it becomes first equation, it becomes second equation. Now what we have to do is we have to subtract 1 from 2. So what we get is 99x equals to 23.535, 35, 35 and 35 minus, will come out to be 0.235, 35, 35 and 35. The number goes on. So when we subtract this, what we get is this part, this whole part will get cancelled out. So what we get over here is 3.32. So we get is 99x equals to 23.3. So the x will be equals to 23.3 upon 99. So further simplification will give us the number as 233 upon 990. So which is a form of P by Q. So this is, these type of questions generally come in examination. So please make a note of these questions. Now further we'll discuss some of the advanced questions and concepts which are generally seen in the examination. So let's watch this question carefully. We have to find an irrational number between the two numbers 1 by 7 and 2 by 7. So we are given with two numbers 1 by 7 and 2 by 7. So we have to find an irrational number. Clearly when we divide 1 by 7 we get 0 over here, decimal, 7 ones are 7, 3, 0, 7 fours are 28, 2, 0, then 7 twos are 14, then 6, 0, 7 eights are 56. So it will go on. So clearly we can say 1 by 7 is 0.1428 and it goes on. And for 2 by 7 we can write like this: 7 ones are, sorry, decimal, 0, then 7 twos are 14, 6, 0, 7 eights are 56, then 4, 0, then 7 fives are 35, then 5, it will go on. So 2 by 7 can be written as 0.285. Now we have to find an irrational number between 1 by 7 and 2 by 7. So we can clearly see that we have range of 0.14 to 0.2. So by inferring this we can write that irrational number can be 0.163875 and it will go on. So this is a solution how to find an irrational number between 1 by 7 and 2 by 7. Now another, there is a trick how to find irrational number, that is, if another part, if 1 by 7 is an irrational number, when we multiply any number with irrational number, then the number will be irrational only. So in the next question we can see the number is 2 by 7 and we can write 2 by 7 as 2 into 1 by 7. So we are multiplying irrational number 1 by 7 with number 2. So this is irrational number. So this means we can write the number between these two numbers as irrational number as 1.5 or into 1 by 7. So which is also a irrational number. Why? Because we are multiplying a number with a irrational number and 1.5 comes in between 1 and 2. So this is another short trick to find an irrational number between any two numbers, provided they have same base. So you have to watch the question very carefully. Now let's discuss another advanced question. The question is, you have to express this number in the form of p by q. Now this is very interesting question, so watch this question carefully. We have number 0.99999, or it can be written as 0.9 bar. So let's solve this question first. So let x equals to 0.9999 and 9. So clearly we have to multiply with 10 only. So we'll multiply both sides of the equation by 10. So we get as 10x equals to 9.99999, and it goes on. Okay, now the next step is, now this becomes the first equation, this becomes the second equation. So next step is we have to subtract 1 from 2. What we get is 9x equals to 9.99999 bar minus 0.99999 bar, and the answer we'll get is 9x equals to 9y, because this part will get cancelled. So the answer will come out to be 9 upon 9. The answer is 1. Now the solution is very interesting, because we have a number 0.9999 and the answer we are getting is at 1. How this has happened? Now when we are solving these type of questions, we are just if you can see the question carefully, by multiplying 10 we are just shifting a one part of decimal to the left. By doing this, we are actually shifting one part of the number to the left. So the thing is, how we are solving this question, we are actually approximating this question by, when we are shifting one part of decimal to this part, and we are left again with a non terminating part, and we assume that it goes to infinity. So that's why this is given in approximation, and but we are getting all answer in approximation. So you have to watch question very carefully, and you have to understand this concept very nicely. So this is the question which is very interesting. So let's discuss the new question, next question. Now you have to express the following, these two questions, in the form of p by q. So let's solve the first question, which is 5.2 bar. Now again we'll assume let x equals to 5.2 to 2, and it goes on, and it goes on. Clearly we can see that we have 1 bar upon 1 number. So what we do is we multiply both sides by 10. So what we get is, we get 10x equals to 52.222 and 2 and 2. It goes on. Then this becomes the first equation, and this becomes the second equation. Then we subtract 1 from 2. So what we get is 10x minus x equals to 52.2222 into, it goes on, minus 2 point, sorry, it will be 5.2222 and 2. It goes on. So what we get is, we get 9x equals to, this part will cancel out, and this will comes out to be 47. So the answer is 47 upon 9. So this is a p by q form. Now let's discuss the second part. The second part is, we have to express 0.001 bar as p by q form. Now clearly in this number we have bar upon 3 numbers, so we have to multiply it with 1000. So you have to watch this part very carefully. You always have to remember that how many bars do over the number the question have. So we'll suppose let x equals to 0.001, 001 and 001, and it goes on. Then we multiply both sides by 1000. So what we get is 1000x equals to 1.001001, and it goes on. Then what we have, this becomes first equation and this becomes second equation. Then what we have to do is we have to subtract 1 from 2. So what we get is 999x equals to 1.001001, and it goes on, minus 0.001001. So this part will get cancelled out. So what we are left with is 999 x equals to 1. So x equals to 1 upon 999. So the p by q form is 1 by 999. So thank you once again for watching this video on edupediaworld.com. So keep watching further videos on number system. Have a nice day ahead.